Hi, hello friends. Welcome to Indian Tech Guru for you. In this video, let us discuss about the concept reliability design. Reliability design using dynamic programming approach. So before actually solving this particular problem, first of all, we need to know what is meant by reliability design. Assume a personal computer which is having single hard disk drive, a single RAM, and a single processor. Now, assume that the hard disk drive as device 1 or D1 and RAM as device 2 or D2 and processor as device 3 or D3. So now to construct a personal computer, we need to have hard disk drive, we need to have RAM, we need to have processor. Then only a complete system can be set up. So how could we set up a system? We can set up a system by having combination of these three devices D1 plus D2 plus D3. So then only it is possible to construct a system. Here the system we are taking the example as personal computer, and the devices we are taking example as hard disk drive, RAM as well as processor. So in case of reliability design, we need to define the reliability of a particular device. Reliability of a device. The reliability of any device will be ranging from 0 to 1. So generally we say a particular device is having the reliability of 90%. Then what does it mean? 90 by 100. That is the value is zero point 0.9. For example, here hard disk drive may have the reliability of 90%. Then D1's reliability, which is represented as R1, is equal to zero point 0.9. Similarly, if RAM is having a reliability of 80%, that is 80 by 100, which is equal to zero point 0.8, then we say that R2 is equal to zero point 0.8, which is the reliability of device D2. Similarly, if processor is having a reliability of 50%, then it is nothing but 50 by 100, that is zero point 0.5. Then we say that R3 represents the reliability of the device D3. So now we know what is meant by a device. We know what is meant by reliability of a device. So here the problem is whenever we calculate the reliability of the entire system. For example, if I want to calculate the reliability of this then the entire system's reliability is equal to product of Ri, that is R1 into R2 into R3. So this will be the reliability of the entire system. For example, if we calculate the reliability of this particular system, then 0.9 into 0.8 into 0.5. So 0.9 into, so 0.8 into 0.5, 0.4, that is equal to 0.36. So here we can see that whenever we take the entire reliability of a particular product, then it will be very low. The reliability is very less. So that's why now what we are going to do is we will propose a system in which we may have more than one instance of a particular device. For example, if we consider hard disk drive, we may connect more than one hard disk drive in a personal computer. Similarly, we may connect more than one RAM, more than one processor. Why we are connecting like that? Whenever we connect the devices parallelly, then the reliability will be increased drastically. So, for example, here I may take three instances of device D1, two instances of device D2, and three instances of device D3, something like this. So, if I consider these many number of instances, then definitely the overall reliability will be increased. Let me erase the screen, then we will continue. So what does it mean to increase the overall system reliability? We need to have multiple instances of a device. Multiple instances of devices. So then only the overall system reliability will be increased drastically. So here, how we are going to represent the reliability? There is a convention for representing the reliability. So to represent the reliability of device 1, the symbolic representation is R power 1. R power 1, this 1 represents the device, first device. Okay, first device is reliability. And we may have the suffix 1 also. The suffix 1 represents number of instances. Number of instances. Now, so R power 1 suffix 1 represents there is single instance of a device or of a device D1 whose reliability is R power 1 suffix 1. Let us assume let us assume R power 1 suffix 1 is equal to 0.9, and assume that I want to replicate the device 1, and now I am having device 1 two instances of device 1. Then what will be the reliability? So to find out the reliability, whenever we have two instances of the same device, then we can calculate the reliability as reliability R is equal to reliability R power 1 suffix 2 is equal to 1 minus 1 minus R power 1 suffix 1 whole square. This is the formula, because I am using two instances of the same device. So that is equal to substitute R power 1 suffix 1 value 1 minus 1 minus 0.9 whole square. That is equal to 1 minus 0.1 whole square. That is equal to 1 minus 0.01. That is equal to 0.99. So what is the value of r power 1 suffix 2? That is having two instances of device 1, then the reliability will be 0.99. Similarly, we can calculate r power 1 suffix 3. What does it mean? Now we are having three instances of device 1. Then the reliability will be 1 minus 1 minus r power 1 suffix 1 whole cube. That is equal to 1 minus 1 minus r power 1 suffix 1 is 0.9 whole cube. That is equal to 1 minus 0.1 whole cube. That is equal to 1 minus 0.001. That is equal to 0.999. So this is the reliability whenever we have three instances of the same device, three instances of the device 1. Whenever its reliability is 0.9. Whenever we have two instances, then reliability will be 0.99. If we have three instances, then reliability will be 0.999. So now let me summarize these values. R power 1 suffix 1 is equal to 0.9. R power 1 suffix 2, that is if we have two instances, then the reliability will be 0.99. R power 1 suffix 3, the reliability will be 0.999. So like this we can calculate the reliabilities. So this is the basic information we need to solve the reliability design problem. Now let us take down a problem and solve the reliability design problem. So assume a scenario like this. We are having three devices, DI. DI values are D1, D2, D3. We are having three devices. And these three devices will have definitely some cost, isn't it? We need to purchase these devices. So their individual cost is represented by CI, that is C1, C2, C3. Individual devices cost is assume like this 30, 15, and 20. And now assume the reliabilities of these devices as 0.9 for device 1, 0.8 for device 2, 0.5 for device 3. And if you know this particular information, then we need to find out the upper bound value of each device. Upper bound value is represented by small u. Then how to calculate the upper bound value? To find the upper bound value, so actually the cost of individual devices are like this 30, 15, 20. So when we are going to have more than one instance of a particular device, whenever we are willing to spend more money, isn't it? Whenever we are willing to spend more money, then only we will be actually purchasing more than one instance of a device. And assume that I am having maximum amount, maximum amount I can spend, maximum amount to be spent is $105. $105. That is, in my pocket, I am having $105 to spend in this particular system, to create this system. Okay. I'm having $105. So assume that we are having single instance of each device. Then first device cost is 30, second device cost is 15, total 45. Third device cost is 20, total 65. So I'm having $105. Total cost of individual devices is 65. So how much is remaining? $40 are still remaining. Using these $40, I will be planning I will be planning to purchase more than one instance of a device. So for that purpose, we need to calculate the upper bound value, which represents that what are the maximum instances a particular device may have. So for that purpose, we need to calculate the UI values. So how to calculate UI values is we can calculate the UI values based on a formula. The formula to calculate the UI values is lower bound of lower bound of C minus sigma Ci divided by Ci. So this is the formula to calculate the upper bound of a particular device. So we know the sigma Ci value. Sigma Ci is nothing but the cost of all the devices, individual devices, 30 plus 15 plus 20, that is equal to 65. And the maximum amount to be spent, capital C value, is given as 105. So we have already calculated this particular value, C minus sigma Ci value. So what is that value? 40. So now let me calculate U1 value. U1 value is nothing but the lower bound of C minus sigma Ci, that is 40, divided by Ci value. Ci means here I is 1, C1, first device cost is 30. That is equal to 1. However, to construct a system, definitely we need to have at least one device. So that's why we need to add that particular device to this particular formula. So 1 plus 1, that is equal to 2. What does it mean? At most you can have two instances of device 1. So let me check. What is the cost of first device? $30. If we have two devices, then the cost will be $60. And assume remaining devices are one instance, then 60 plus 15 75, 75 plus 20 95. So it will be below the maximum amount to be spent. So that's okay. Assume that you are purchasing three instances of device 1, then 30 into 3 $90. 90 plus 15 105. You cannot have device 3, even single instance. What does it mean? You cannot construct a system. So that's why definitely we need to have at least one instance of each device. Then only it is possible to construct a system. So that's why for this particular value we need to add plus 1. So the maximum devices, at most devices we can purchase of device 1 is 2. Next, let me calculate U2. U2 is equal to lower bound of 40 by 15. So that is equal plus 1. That is equal to 15 twos. 2 plus 1, that is equal to 3. So I can purchase at most 3 devices of D2. Similarly, U3 40 by 20, lower bound plus 1, that is equal to 2 plus 1, that is 3. So we can have at most 3 instances of device 3. So now we have the data such as how many number of devices are there, what is the cost of individual device, what is the reliability of individual device, and what are the upper bounds, that is at most how many instances of a particular device we may have. So based on this particular table data, now we can solve the problem of reliability design. So in this reliability design problem, what we need to find is how many instances of a particular device we need to purchase so that it will not exceed the maximum amount to be spent, and which will lead to optimal solution. So the solution for the reliability design we'll be discussing in the next video. Hope you understand the logic till now. That's all for now.